Hello, everyone. My name is Juraj Oršulić. I'm affiliated with the Laboratory for Robotics and Intelligent Control Systems at the University of Zagreb. And I'd like to share with you my experience with some deterministic debugging, which I think fits nicely into the theme, which Brian from Fetch started one presentation before this, the previous one. So I will be sharing with you my story about Mozilla RR and how I used it to debug a problem in SLAM. So Mozilla RR is a tool which performs a lightweight process execution recording. Only the non-deterministic inputs into the process are recorded, and afterwards you perform debugging by replaying the process with the same executable. So the non-deterministic inputs that were recorded are then passed back to the original executable, and the result is that you can replay your process with an accuracy down to instruction level. And you can use a GDB interface to debug the replayed process, and you can go back and forth in this replay, which is very cool. So you can put a breakpoint, then call JDB's continue, and you can also call reverse continue, so the process execution will jump back to where that breakpoint was hit. I will have a short demo afterwards. So RR sits between the process and the kernel, and it records all non-deterministic inputs. So this would be a reading for a file, reading from standard input, reading for network. In case of when you would record a ROS node, this would be the incoming network packets containing the subscribed messages. So here, for a simple program which would just read in two numbers and sum them up and display them, what would be only recorded would be these two numbers. And if you have the original executable, you know that what the executable does is that it adds these two numbers together and prints them out. So this makes for a lightweight recording of the executable. So in case of a ROS node, the non-deterministic inputs would be the incoming messages. So the issue I ran into was that the only output, so in the previous example, the side effect of this application is printing this to the standard output. So the only side effects that Mozilla RR reproduces is standard output. This means that we do not get messages which were published in the original execution when we are doing the replay. And then I really wanted to visualize what was going on inside the replayed process. So I hacked together some Python ROSPy JDB hooks which republish the messages when you are replaying the recording, just like they were published in the original, during the original execution. So there are some limitations, of course, even though RR really can produce lightweight recordings. I think it's somewhere around 50 megabytes for an hour or process execution. Of course, depends how much data you have streaming in. You need to have a recent Intel processor. Their support for AMD processor has been merged recently, though. And one major limitation is that multi-threaded processes are executed sequentially. This means that you do not get the speed up by parallel execution. Although, if you are trying to debug multi-threading issues, RR can help you in a way that it supports a chaotic thread scheduling mode, which helps provoke multi-threading race condition bugs. So there are some ideas for the future. There is a GitHub link for at the end of the presentation, so you can try this out for yourself. Things are a bit of proof of concept hacky currently, but it would be nice if we engaged with upstream RR. I would like to give a shout out to Robert O'Callaghan, the RR Kiwi hacker, who is the principal architect for creating such an amazing tool. And some possible applications might be just let it run and record what's going on in your nodes running on your robot the entire time. And if you record some rare occurring bug, you recorded it, and then you can replay it and debug it. This is the last slide, but I still have a demo to show you. So the reason why I looked into Mozilla RR was when I started working on Google Cartographer, and I encountered, this is an older build from, I think, 1.5 years ago, and I encountered some issues with it, and when I was trying to debug them, that's how I discovered RR. Oh, the video is not showing. Okay, so now I'll be recording an execution of the cartographer offline node, which crunches a bag and builds a map and a trajectory. Now you'll see that this older version had a bug where the post suddenly diverged. Here's a slow motion replay. And it's gone. Okay, so what I'll now do is I have made an RR recording, and I'll jump back to the RR event number 790,000. The crash occurred at the event number 830,000. So I jump back to a bit earlier point in time. Now I call my hack, which republishes ROS messages, and now we have all messages from the replayed recording being republished. So now it crashed again. Now I go back again, this time a tad further. And the cool thing is that now I'll put a breakpoint at the function which publishes the pose estimate. So now we stopped at this function, but we don't see a pose yet because the breakpoint is at the beginning of the function. So we hit continue, and we get one pose. Then we hit continue again, and again. Oh, we see the first one, which is problematic. Now we go back. And we hit the breakpoint again, but backwards in time. So this is a spaceship against regular JDB. Now we print the timestamp where we calculated. So the cool thing is it's JDB, so you can use it with an IDE. And that concludes the demo and the presentation.
Time for one quick question. Okay.
So right now right now to integrate RR with your ROS publisher hack, is that a lot of work, or is...
The republishing script is on GitHub, so it's a GDB hook. A proper thing to do would be to integrate a plug-in system into RR for reproducing side effects of replayed processes. So currently, the only thing you get is the standard output. And the only introspection you can do is by inspecting the variables through GDB. And it would be cool if there was a generic system for reproducing side effects, and replaying published ROS messages would be a prime candidate for such a plugin. So I haven't engaged with RR upstream yet. They actually don't know about this, but I hope they will.